Assalamualaikum warahmatullahi wabarakatuh. My name is Athirah Binti Muhammad Azemi, and today I am excited to share my research for the Geomatics Research Innovation Competition 2026. My study is titled Assessment of Shoreline Change Rates between 2016 and 2025 using Automated Water Extraction Index along Kuala Terengganu coastline. So, why shoreline monitoring matters? Let's start with a reality check. Why are we even talking about shorelines? Look at the picture on the slide. That isn't just sands, that's a crumbling road threatening homes and livelihood. Kuala Terengganu is beautiful, but it's incredibly dynamic. Its coastline is constantly fighting natural forces like crazy wave action, sediment movement, and especially the fierce northeast monsoon. On top of that, human development messes with the sand's natural flow. So, what exactly was my mission here? I set out with two core objectives. The first one is I wanted to map out and analyze exactly how much the Kuala Terengganu coastline has actually shifted over this 9 year gap. Secondly, I wanted to pinpoint the exact hotspot location, which means where is the beach losing ground to erosion and where is it gaining sand through accretion. To find out, I focus on three highly popular and vulnerable beaches, which is Pantai Tochembal, Pantai Cenderung, and Pantai Kuala Ibai. Move to the methodology. So, to find out how much the Kuala Terengganu coastline has shifted between 2016 and 2025, I use a smart automated approach instead of clicking and measuring everything manually with a ruler tool. First, I extract the shoreline data using the AWEI formula. Since the raw line came out looking like blocky stairs due to the satellite pixels, so I ran a small tool to clean up the geometry. So it will making the lines look much more natural and aligned with the actual coast. I also made sure that everything was set to the correct local map projection, which is for the Terengganu grid. So the measurement wouldn't get wet. So the measurement wouldn't get wet or distorted. To actually calculate the distance without crashing my laptop, I decided not to create heavy cross-section lines. Instead, I used a tool called Points Along Geometry to automatically drop a marker point every 100 meters along the 2060 shoreline. This gave me a really clean, evenly spaced set of points. So then I ran the distance to nearest hub tool, which basically acts like an automated tape measure. It measures the exact distance in meter from each 100 meters points on the 2000 line straight to the closest spot on the 2025 line. So in the end, you just save all the measurements in the attribute table. So I just exported the table into Excel to easily figure out the average of erosion rate as well as the absolute maximum distance the beach have moved inward or outward. So to wrap it all up and make sure the data actually made sense in the real world, I double check the finaliness. I check the finals against a Google satellite based map to confirm that the numbers match up perfectly with what happens on the ground the calculated distance from the QGIS attribute table and exported them into Excel to run some basic statistics. Instead of just throwing raw numbers at the readers, I broke the results down by calculating the overall average shift of the Terengganu coastline, which clearly shows whether the area is generally experiencing accretion or erosion. I also highlighted the absolute maximum erosion and accretion values to pinpoint the exact hotspots where the beach changed the most over the 9 years. To make it super easy for my supervisor and my examiners to digest, I organized this number into a clean summary table alongside a map layout featuring the Google satellite background, which visually maps out exactly where the critical coastline changes are happening. Let's talk about the why behind these patterns. So the biggest culprit here is the northeast monsoon. Every year, it slams the east coast with intense wave. When you combine the heavy weather with man-made structures on the beach, it completely disrupts the natural balance of sands. So on the technical side, automated water extraction index (AWEI) was a total lifesaver. It proved that we don't need ultra expensive tools to get sharp results. which means it cuts through all the shadows and complex coastline effortlessly. This means that method this means that the method is absolutely perfect for monitoring tropical coastline right here in Malaysia. Last but not least, to wrap it all up, what are the big takeaways from my study? First, Paris Sentinel-2 with AWEI is a highly practical, fast and budget-friendly way to keep an eye on our changing planet. Second, our coastline are moving targets which are experiencing both intense aggression and also erosion over the last decade. And most importantly, this data isn't just for show, it gives local authorities that exact blueprint that they need to protect our beautiful beach. The ministry or local council, here is what I will recommend. The first one is to make it a routine, so don't wait for a disaster. Use satellite tracking to monitor the coast regularly. The second one is to double check on the ground. So the future researchers should back this up with direct field observation to make the data bulletproof. The third one is go bigger. So let's copy paste this exact workflow for other high risk coastal states in Malaysia like Pahang or Kelantan. And the last one is to target the danger zones. We will use the maps to build defense exactly where the erosion is hitting the hardest. With that, I want to say a massive thank you for your time and attention today. That's all from me. Thank you.